Now that we have reviewed percents and have been doing a couple of different types of problems in class, now I want to focus on two-step problems and this idea of what do I need to answer, percent change, and then finally simple interest. So with two-step problems, some of us have made it through these with a little bit of ease, and others are a little bit confused as to what it means or what you need to do when you are asked to solve one of these problems. So over on the left-hand side in pink, it says most of the time you are asked to find the part or the is when calculating the tip, tax, or discount in a problem. And over on the right-hand side, here's a reminder. If the question asks for just the amount of tax, tip, or discount, then it is one step, meaning you just find the part. But if the question asks for you to find the total with tax, the total with tip, or the price after discount, then you have to complete another step. I'm going to do a couple of these on the next few screens, and then I'm going to have you stop and try one on your own. So let's start here. You want to buy a new watch that is marked $86. There is 8% sales tax. How much do you have to pay in tax? So if you are asking yourself a question here, you really want to know what is 8% of $86, okay? So in thinking about that, what is, I don't know my is over of equals percent out of 100. If I don't know my problem is going to be set up with X in my is. The watch is $86. I know that I have to pay 8% tax, and that 100 is always there. With this setup, this is a one-step problem. So I'm going to go ahead and cross multiply. And that means 86 times 8 is equal to 100 times X. 86 times 8 is 688 equals 100x. I can divide both sides by 100 to isolate my x, or to find out that x is equal to $6.88. Okay, that tells me the amount of tax I have to pay. Okay, how much tax do you have to pay? My tax is right here, $6.88. But now, if the question becomes, let me see if I can shrink this down here. Oh, I'm losing the wrong notice. Okay, so let's see if I can shrink now. That's not what I want to shrink. I'll shrink this down, I guess. Sorry about that, guys. And I want to bring this up. Now the question says, how much will you pay in total for the watch, including tax? So if I look at those words carefully, in total for the watch, including tax, okay? All of those key words should indicate to you that we have to pay, oh boy, $86 plus $6.88. Now I'm going to add those zeros there for us to notice our place value. So I'm going to have 6 plus 6 is 12. I will have to pay, in total, $92.88 for the watch, including tax. So this second part here is where we notice that now this wasn't just a one-step problem, but it was two steps. All right. When Mrs. Smith went to a restaurant, her bill was $60. Mrs. Smith wants to leave a 20% tip for the waitstaff. How much tip will Mrs. Smith leave? So in looking at this problem, we really need to just answer this. How much tip will Mrs. Smith leave? 20% tip out of the $60 bill is going to indicate to us that, again, we don't know our is, we know $60 is our of, and this is 20% out of that 100. So we're going to cross multiply and divide. All right, 60 multiplied by 20 equals 100 multiplied by x. Notice I'm writing out these steps. It's not for me, it's not just for you, it's about your process and understanding where these numbers are coming from. So 60 times 20 is 1200. 100 times x is just 100x. We're going to divide both sides by 100 and find out that x is going to equal $12. Okay, $12 answers the question of how much tip will Mrs. Smith leave? So now let's look at the next part of this question. If Mrs. Smith came to the restaurant with $90, how much money will Mrs. Smith have left over after paying her bill and leaving the tip? Oh, this is more than 2 steps because now we've already found out the tip, but I need to know what is her total with tip, and then what does she have left over? All right, so Mrs. Smith, remember, spent $60 on her meal. She's going to leave a $12 tip, meaning that she has spent $72 on her meal. Okay, and in knowing that, now we can go ahead and answer this question. Okay, and that means that here she came with $90. She has to pay $72. How much is she going to have left over? So hopefully we can just go ahead and do 90 subtract 72. And we will notice that Mrs. Smith is going to have $18 left over. Okay, so that problem wasn't tricky in the sense of the math that needed to happen. It was just about the words and understanding what's being asked of you so that you answer the right question. Okay, that's what's a little bit more tricky than anything with these percent problems. Sweet, now it's your turn. You get to do this one. You want to give your favorite teacher a birthday present. You have found a t-shirt that will be perfect. It is marked $32 but is on sale for 15% off. How much will you save on this perfect present? And then answer, how much will the perfect present cost after the discount? Pause the video, do the work on your paper, considering this idea of discount, the keywords that I've highlighted for you, 15% off, you save, and after the discount. So think about those words and what you might need to do to get a good answer. Hopefully you've taken the time to answer both questions that were on the previous slide. And if you did it correctly, $4.80 will be saved with that 15% off. And the perfect present will cost you $27.20. We will continue to do more of these problems in class, but for right now, we're going to switch gears and talk about percent increase. Okay, so percent change. You don't need to write all of these words down, but you just have to be able to understand what is happening here, okay? And it might take you a couple of times to watch the next couple of minutes of this video, pause it, rewind, rewatch, whatever you need to do to try to internalize it so that when we do problems in class, you'll have a better understanding of what needs to happen. So percent change. You are often asked to find the percent in these types of problems. This means you're usually given the is and the of. You know the part and you know the whole. But it's tricky for you to figure out how to set these problems up, meaning which one is the is and which one is the of. So we're going to practice with the problem that's down below. It says, Miss Saarinen has been practicing her typing skills. Last month, she was able to type an average of 78 words per minute. This month, she typed an average of 105 words per minute. What is Miss Saarinen's percent change in her typing speed? I'm going to show you 2 different ways that you can think about these problems, and you are going to be able to choose which one works best for you. Okay, so when I look at this problem, I am going to think about this idea that there was an old amount and there's a new amount. And so I'm going to use this idea of new over old is equal to percent out of 100. And I don't know the percent, so I can already start to set this up with x is over 100%. All right. And if I use this new ratio in my proportion setup, new compared to old, I'm going to go back and reread. And it says last month, Miss Saarinen typed 78 words per minute. And then it says this month, she typed an average of 105 words per minute. So I've got a new number and I have an old number. My new number is going to be most current. So that's going to be the 105 words per minute. And the information from last month will be my old information, which is the 78. Okay, I'm still going to use the same process. Cross multiply and divide. So 105 times 100 is going to give me 10,500. Sorry about that, sloppy 5. And that's going to be equal to 78x. Okay, so now I'm going to divide both sides of that problem by 78. So 10,500 divided by 78. And divide by 78. X gives me 134, 134, and I'll say 62 hundredths is the way that I would round that. As if you look, it says 134, 6, 1, 5, 3, 3, not 3, 3, 3, 8, 5. So to round that to the nearest tens place, I want, look at the 1, look one digit beyond it, that's a 5. It's 5 or more, so this is going to become a 2. And then the rest of that just goes away. Okay? All right, so let me erase that so that's not a distraction. But we're not done. Because that answer, most of you say, wait a minute, I'm at 134 and 62 hundredths percent. That seems crazy. That doesn't seem like a percent change considering what has been asked. I haven't increased my typing by that much, okay? So with this percent change thing, once you find your x, you're going to take your x answer and subtract 100 from it, okay? And that is going to help me communicate what that percent change is. So for this problem, I'm going to go ahead and say that 134 and 62 hundredths subtract 100 is going to give me my percent change. All right, and so quickly I can see that I would have 34 and 62, I'm having a rough time with my numbers, 62 hundredths percent change. Okay, that change is a positive change. So here it's going to be 34 and 62 hundredths percent, and I can actually say percent increase. Okay, because that allows me to see that I have increased my typing speed. Okay, so I'm going to now do this one other way using the exact same numbers, and we hope to get the same exact answer. Okay, same words, same situation. We're still answering the same question. What is Miss Saarinen's percent change in her typing speed? So this time, instead of setting up my proportion first, I'm going to find that change first, okay? So to find the change, okay, I'm going to take 105, subtract 78. And that's going to let me know that I have a change in my words. So 105 minus 78 gives me 27. Okay, so that's a 27 word per minute increase. I'll just abbreviate with that arrow from one month to the next. Except for that it doesn't ask us what was my word per minute increase. It wants to know my percent change. All right, so in that instance, instead of this new over old, I'm going to indicate my change over the original is equal to percent out of 100. Okay, so now we're going to start to set this up just like every other proportion problem that we've done. I'm going to put in what I know. Okay, I know that the change is 27 words per minute, and the original number was this 78. Okay, 27 over 78 is equal to percent, x percent, over 100. Okay, so we're going to still cross multiply and divide. And 27 times 100 is equal to 78 times x. 27 times 100 is going to give us 2700 is equal to 78x. Isolate your x by dividing both sides by 78. And it shows me that x is equal to 34 and 62 hundredths percent. Okay. On the previous problem, I did the exact same. I had the exact same answer, even though I did the steps in a little bit of a different order. Okay. I would encourage you to stop the video, go back and re-watch the last 6 minutes, okay, and determine which way do you think it's going to make the most sense for you, okay? Do you want to do your percent proportion and then subtract at the end, or the second way, subtract first and then set up your proportion and get an answer? It's totally up to you and whatever way is making most sense and whatever process is most comfortable for you. Okay, so now let's try to do this one together. You're going to choose the process. I'm just going to kind of help you with the numbers. All right, so it says Melody bought a pair of shoes last month for $65. This month, she notices that the same shoes are now priced at $51. What is the percent change? Okay, so like I said, you need to make a decision. Okay, there's basically two ways in which this can work. The first way is you are going to set up your proportion, okay, and do, let's say, that new over old percent out of 100, and then at the end, you subtract 100, and that'll give you your percent change, okay? Go ahead and do that method if that's what works for you. The other method is to find the change, okay? So find change, okay, meaning subtract. All right, and you don't need to do the math so that it's all in negatives. You're noticing with this problem that Melody's shoes have now been marked down. That means that there's going to have been a percent decrease because the shoes are less money this month than they were last month. Okay, so you can find the change, and then that means you're just going to have subtracted. Okay, and then once you know that amount, you are going to set up your proportion so that we have change over the original is equal to percent out of 100. Okay, doesn't matter which process you use, you should get the same answer no matter what. Pause the video, do the math. You can even do it both ways and then see if you do get the same answer. And after you've paused and done that, I'm going to go ahead and share my answer. Okay, did you do it? If not, I'm serious. Pause, go back to the screen so you can see what I'm talking about, and do the practice right now. All right, so the percent change on the shoes that Melody bought is a grand total of 21.5%. Okay, we can round that to 21.5 because the number after the 5 is a 3. It's less than 5. All right, so it's going to stay the same. So 21.5%, and we're going to indicate that that's a percent decrease. Okay, the other way we could say that is just negative 21.5%. That would indicate to me that it is, in fact, a percent decrease. Okay? All right, now it's your turn. Last year, you earned $3 a week in allowance. This year, your responsibilities have increased, so your allowance is now $7 a week. What is the percent change in your allowance? Go ahead and do this problem. All right, choose the method that works for you, and then I'm going to display the answer in just a few seconds. Did this one trick you? You'll notice that $7 a week is actually double what your allowance was last year per week. So when you do this problem, you are going to end up with, as a percentage, possibly what looks like to be 233 1/3%, and then you have to subtract that. All right, so if you do that, then your answer, I'm going to just quickly show this. So 7 is the new, old is 3% over 100. All right, when you do the math, you get 233 and 1/3%. If I subtract 100 from that, I have a percent increase of 133%, okay? Because I'm getting not just 100% of what I earned before, that would have been $3. So I'm getting an additional 100%, which takes me to $6, and then that extra dollar, which is that 1/3 of the original. So 133 and a third percent of an increase. That's a pretty good deal. All right, now if you're somebody who likes the other method, okay, then go ahead and think about that change first, okay? The change first is 7 subtract 3, okay, giving me a change of 4. And then I set up my change over the original, which was 3, is equal to percent over 100, okay? And again, when you do that math, you're going to end up with a percentage of 133 and a third percent increase, okay? So it's important not just to be able to do the math and kind of, as I say, plug and chug the numbers, but to be able to look back at the information and make sense and have that number sense to realize that $7 is actually quite a bit more than what you started with, okay? And then complete 100% more than that $3, taking you to $6, and then that extra dollar. All right, we're almost to the end of the video. The one thing that we still need to talk about is this idea of simple interest. Okay, and simple interest is something that can be calculated if you're going to borrow money, or let's say you invest in some money, okay, there can be interest calculated. Now we're going to talk about simple interest because it's a lot easier than compound interest, okay? So there's two different types, and we're going to use simple examples, even though some of the real life applications would likely use compound interest, okay? So there's a formula, and I'm just going to throw that up on the screen right now. It's actually I for interest equals PRT, okay? P is for the principal, or the amount of the loan, or the amount invested. The R is considered the rate, and I'm just going to indicate that that's always a percent. And T is the amount of time that you have borrowed the money, or the amount of time that you invested the money, and that time is always represented in years, okay? So we can think about this formula, and a lot of times you'll be given the formula, and then you need to know how to manipulate the information in a problem to make this formula work for you, okay? So interest is equal to the principal multiplied by the rate multiplied by the time, okay? I'm going to do a couple with this formula and kind of identify the different pieces, and then I'm also going to show you a way in which you could find the simple interest on a loan or on an investment using all of the same proportion and percent setups that we've been doing for the last several days in class. Okay, here we go. Okay, so Miss Hawkins invested $250. The investment will earn 4% interest per year. How much interest will Miss Hawkins have earned after 3 years? Okay, so let's go ahead and set up this problem using some of that information from the previous screen. So I'm just going to write that down at the bottom here. I equals, so interest equals principal rate time. Okay, interest equals PERT, if you want to say it. I don't know, I just made that up. Anyway, so we want to find out the interest, right? How much interest will Miss Hawkins earn? So I already know that that's going to be my unknown, okay? Everything else is going to be given to me. So the principal, okay, remember, is what was invested, okay? So I'm just going to write that down. So principal is going to be 250. The rate is the percent, but here's the catch, folks. This has to be used in that decimal form, Okay, so 4%, remember, is 4 out of 100. So to write 4% as a decimal, I really have to think about doing 4 divided by 100, or moving that decimal place 2 places to the left. So my decimal for 4% is actually going to be 0.04, or 4/100ths, okay? And then the time is 3 years, all right? 3 years I'm good with because it's already in years. I don't have to do anything to change that. So back up to my formula. Interest PRT, 250 multiplied by this decimal, 0 and 4/100ths, multiplied by my time, which is 3. Now, here comes the easy part. Just use your calculator to get an answer. 250 multiplied by 0.04 multiplied by 3. Okay, that gives me $30. Okay, interest earned on a 3-year investment is $30. That means that at the end of the 3 years, okay, Mrs. Hawkins still has that $250, okay, and she has earned an extra $30 just for having it there, okay? So it's a little bit more like a savings account. So 250 plus 30 is going to give Miss Hawkins, $280 of an investment after those 3 years, okay? Let's do it again, but this time I'm going to set it up using our percent ratios, and you guys can choose which one works for you. Okay, so for this same problem, I can think about finding 4%, oh, I need a different color, 4% interest on $250, okay? So is over of, oh, this is so familiar and nice to me, percent over 100, and fill it in, okay? I don't know what that is going to be. I know that Miss Hawkins invested 250. I know that that percent is 4% out of 100. So when I cross multiply and divide, this is going to tell me for 1 year, all right? Because it's 4% interest per year. So that's what's really important to remember. So cross multiply and divide. So 250 times 4 is going to be 1,000 is equal to 100x. So when I take 1,000 and divide it by 100, I'm going to get $10. Okay, that's $10 for 1 year. Now go back and read the problem again. How much interest will Miss Hawkins have earned after 3 years? Okay, so simply stated, we know that 1 year is $10. All we need to do for 3 years, okay, is do $10 multiplied by 3, and that would give us a $30 amount of earned interest, okay? Sorry, I lost my train of thought there. So $30 earned interest. That's the same value we had using our I equals PRT, or interest formula, for calculating simple interest, okay? So let's put another one up, try it, and then we're going to complete more of these in class in the next couple of days. All right, so Gary borrowed $700 from his dad, but has promised to pay him back, including 5% interest, okay? So you have to understand that when somebody borrows money, this isn't about you making a decision to say, oh, I'm going to take the $700 and then I'm just going to pay back 5% interest, okay? You're actually paying back the $700 and 5% interest, okay? Because that's showing the person who, like, they're going on good faith here that, yeah, you're going to use that $700, but because I gave you that money, you have to pay me back a little bit more because I didn't have that money in that 2-year period of time. You had it. Okay, so that's where it's a little bit difficult to kind of put that together. All right, I lost the rest of my problem here, which is a bit of a problem, quite literally. All right, there we go. So Let's set this up using that formula quickly, okay? So I equals principal, rate, and time, okay? And I'm just going to kind of look over here and I'm going to say, okay, Gary said that he's going to pay back in 2 years. That's my T. I see that Gary borrowed $700. That's the principal. And then remember I said that that 5% was the tricky piece, okay? And hopefully you remember that that 5% has to become a decimal, okay? And that decimal means, okay, that it's 5 out of 100, okay? So that's going to give me 5/100ths as decimal notation, okay? I can take those three numbers now and multiply them together. So those three numbers again are the 700, the 5/100ths as a decimal, and the 2 for that 2 years, okay? If you multiply that together, you will get the amount of money, the amount of interest Gary owes his father. So 700, I'm doing it on the calculator right now, multiplied by 5/100ths, multiplied by 2, indicates that Gary is going to owe that $700 plus $70 in interest. Okay, so again, if you would rather use the information of our setup with proportions, you totally can do that. Okay, he's going to pay back at a 5% interest rate. He borrowed $700. We don't know what that interest is. But remember, this is for 1 year. And Gary's actually borrowing that money for 2 years. Okay? So when you cross multiply and divide, 700 times 5 is going to give me 3,500. 3,500 is equal to 100x. Isolate your variable, and I see that 35 is equal to x. Again, that's for 1 year. For 2 years, I have to take 35, multiply it by 2, and find out that the interest is $70. That $70 shows the same value that I had up above. Okay? We are going to practice this in class. You can use whichever method works for you, all right? We just have to be able to dissect those words and then put them into the appropriate place, which will allow us to answer the question appropriately. All right, heroes, you made it to the end of the percent video. I know that there's a lot of information in here, okay? But the idea is that we watch it, we take the notes, we practice, we go back and watch again so that we are secure with our skills, okay? Please don't panic, okay? Please make sure that when you come to class, you have these notes, or if you happen to take the notes in class, please make sure that you are understanding what you are putting down on the piece of paper, okay? It's really important. I don't want you to write a transcript. I just want you to have some notes, some examples, so that as you do practice in class, you're able to follow along, okay, and gain this new knowledge. If you have any questions, you can, of course, ask me in class, ask me before school, at lunch, after school, or through Edmodo. Have a good night.